Swayam Prabha. Digital India. Educated India.
Welcome to Module 6. This is Waste Processing, Recycling and Recovery Planning, and we would start the first lecture, which is part 1. This is lecture number 26. The concepts that we will cover are what we have already learnt a little bit earlier as well, that is concept of 3 R's: reduce, reuse and recycle. Then we will talk about integrated solid waste management, then recycling benefits and opportunities, recyclables in MSW, potential material for recycling in MSW, material recovery facilities, stages of material recovery, and finally a case studies on material recovery facility. So we have already learnt about the concept of 3 R's, where we talk about initially reduction of waste and then eventually reuse and recycle of waste. So first, of course, is the process of waste reduction, where we want to generate less waste in the first place, and we want to prevent or reduce production in the first place. So that's the first stage of it. And then whatever waste is being produced over here, you can see we will consume it. That means we use the product and we will try to reuse it again, right? So we can discard the product. That means once we have used it, we will discard it, but at the same point of time, there will be somebody else who wants to use the product again. That means when you sell a car and then it is being bought by another person and used again, then it's a reuse of that particular product, right? So that means we are again, instead of production, we are again going back to the same point where it is being consumed, right? So once it is discarded, then after that, if we cannot reuse it, then we should definitely think about doing something about it. In that case comes recycling, composting and recovery. So this recycling, composting, these are different processes, of course. That means we can recycle some of those quantities that we are discarding, maybe as a whole or maybe as a part, or we can also go for, if it's an organic matter, then we can convert it and then we can convert it into fertilizer and then we can use it as compost. Then that is composting, and then we can also do recovery of certain materials from the waste streams we can use, right? So that means certain materials, instead of sending for final disposal, we will try to use them, or we have to do some amount of processing to those particular materials, and then we can again put them back into the production process. So that means instead of getting natural input materials or virgin materials from the mines or from the environment, instead we get some of those materials back from the discarded products. So the product itself can be reused, or components of the product or parts of the product after certain amount of processing can be again taken back to the production process, which will reduce the amount of natural materials that are required to produce that particular product. So once nothing works, that means we cannot recycle, we cannot reuse, we cannot compost. In that particular case, we will finally dispose of the product in the landfill site. So that is the concept of 3 R's. Now, some people have even said that instead of 3 R's, we can also think of 6 R's. For example, people have talked about rethink, then refuse. That means first you think about the usage of the product and why are you using it and what could be the alternatives and so on. Then you refuse, like you refuse to use extra, and then you reduce, right? So you reduce the quantity that you are consuming. Then once you are doing that, then you can reuse, you can repair it to a certain extent and again reuse, or you can recycle it. Recycle could be in different ways. So these are also other ways people have proposed this particular concept using the R's. Some have given 3 R's, some have given 5 R's, some have given even 6 R's. So our primary goal is to reduce the final volume of waste that is going for disposal, and we need to reduce both the volume as well as the toxicity of waste. So this is a basic concept. That means not only we are trying to reduce the total volume that is going to a landfill site, but we are also improving the quality of the waste that is going, or the final waste that is going to the landfill, by improving its quality or reducing its toxicity, right? So that means we have to take out the toxic materials so that it doesn't contaminate either the groundwater or the soil, surrounding soil of that particular landfill site. So once we are reusing, recycling, all these things are done, we will still find that there is something intermediate between sending our waste to the landfill site and utilizing it. That means uh, what we can do is we can convert our waste, or we can convert it to energy. That means if I have got organic waste, then I will definitely compost it. If I have got inorganic waste, I will try to recover all the materials which can be reused or recycled from that. Whatever remains, I will then take a look at it and see if that waste we can generate some amount of energy. So that is where we have already learned this earlier, that if the waste has a calorific value higher than a particular threshold, which is 1500 kilocalories, in that case we can actually use that, we can actually burn that product to produce energy, right? So either by incineration, or by pyrolysis, or this kind of combustible technologies, or in other technologies like biomethanation, which are chemical biological processes. Using those, we can also generate some amount of energy. So energy recovered through incineration, anaerobic digestion, which is biomethanation. Actually, biomethanation actually generates the methane gas, which could be used to burn and produce energy eventually, right? Or sometimes the waste would be directly burned, which is through incineration. So using this, we can generate energy, but of course, this will result in some amount of emission, which is also not good for the environment. So we have to take a call. Should we go for energy production, or should we go take the waste to the landfill? So whichever is better overall, that we have to choose. And sometimes we have limitations, like we don't have adequate area for landfill site, right? So in that case, incineration may be a good option. Or maybe the waste is so good that we could be able to generate a lot of energy, and we could reduce the burning of fuel, like burning of coal or burning of oil for generation of electricity. So in that case, we can also burn waste as well. So ultimately, whatever is remaining, the residual solid waste and the processed rejects, this goes to the landfill site. Okay, so that means the minimum amount of waste, which is the final quantity, which we cannot do anything with, that goes into the landfill site. Now, this 3-year approach basically is a shift from a mass consumption society. So this is the background theoretical perspective, you can say, like we have to shift from a consumption society. That means our society is geared towards consumption. You produce more, you consume more, right? Everybody is trying to do that, to a life cycle economy and a sound material flow society. To a life cycle economy means we have to consume those things which are environmentally friendly over its entire life cycle, right? Not only we can say it's a green product, but we have to see how much energy is being used to produce it, what kind of processing it requires, if the entire life of this particular product is green or not. So we will learn about life cycle analysis later. And the sound material flow society means each material, it has to be utilized, reutilized as many times as possible. Eventually, it may go to the landfill site, but we have to keep on using it so that we reduce the use of natural material or virgin material. So, with minimal use of natural resources and minimal adverse environmental impact. So, that's the overall goal. Keeping this goal in mind, we have to design our recycling system or designing our waste management system. So coming to integrated solid waste management, we have already learnt about this earlier. So the first step is, of course, to at source reduction and reuse. That means we need to reuse the product again and again, or reduce the use of the product in the first place. So that's the first step, right? So this is the demand side, what to say, demand side approach to reduce the consumption of waste, generation of waste, or so on. But once the waste is product is being consumed, then the waste is generated. Then we have to really think about the weight fractions of the waste and the dry fractions of the waste. So for wet fractions, we will try to go for composting, and we can also go for another method which is called biomethanation. So composting and biomethanation both utilizes organic waste to generate some amount of products which we can use. Composting generates mostly your manure or fertilizer, whereas biomethanation generates both this CH4 gas, because it's the difference between the processes, the biological process that we employ. In composting, we employ aerobic processes mostly, not always, whereas in case of biomethanation, we use anaerobic process, which leads to more amount of methane production. Now, when more amount of methane is produced, we can use it as energy. So, this wet waste can also be converted into energy. Whereas dry waste, some of it can be recycled. We will try to recycle some of the waste so that we can recover some of the product. Some of it can be used as, could be converted to energy by burning it. So we have incineration, or we can convert it into a material which could be used as a fuel for some other industry or so on. So refuse derived fuel. Or it could be used as co-processing of combustible dry fraction of waste, which is whenever, like in cement industry, in other industry, we can use this as a material which could be used for co-processing and for burning or generating energy in those industries as well, right? So this is where this dry waste also could be utilized. So once all this utilization is done, whatever remains goes into the landfill, as we just discussed earlier. So coming to the definition, recycling is recovery of commercially viable materials, valuable materials, or you can say viable as well. Example, plastic, paper, metal, glass, e-waste, C&D waste, all this comes under, the recycling programs. And this is usually from non-biodegradable waste. But if the waste is mixed, sometimes, we don't have the wet or dry waste separated at source. So in that case, the waste is mixed. In that case, if the waste goes into the composting process, we may need to do pre-sorting of that particular waste, and we may generate some amount of material which could be recycled as well, right? So, but in general, we say that dry waste component or non-biodegradable waste could be recycled. Composting is the conversion of biodegradable waste to fertilizer via composting and vermicomposting. This we will learn in the subsequent lectures. And waste to energy is energy recovery from waste during final disposal, and different processes could be employed, such as biomethanation, which is using organic waste or wet waste, refuse derived fuel, co-processing of combustible dry fraction of waste, and incineration. So this is the three options that we have got to reduce or reuse or to adhere to the 3R principles. So coming to Software Management Rules 2016, what it states about recycling is the process of transforming segregated solid waste into new product or raw material for producing new products. So that means we transform segregated solid waste into a new product or raw material for a new product. So directly we can make it into a product, or we can create raw material using which we can create a product. And not only that, there has to be arrangement made by ULBs to provide segregated recyclable materials to the recycling industry through waste pickers or any other agency engaged or authorized by urban local body for the purpose. So that means it's not only the recycling process is now mandatory, but also making sure that recycling industry is supplied by materials, as well as engaging waste pickers and other informal workers to do the sorting and all those other work that is required to recover this kind of materials. This is made mandatory for the urban local body. So what are the benefits and opportunities in regards to recycling? Of course, it reduces environmental impact and landfill space requirement. Then market linkages and extended producer responsibility is very, very important. Why? Because I may recycle a lot of products, I may get a lot of products from my waste stream, but at the end of the day, I have to have markets to sell them, or I have to have certain agencies or certain agreements with certain recyclers so that they will take my product. If I am not able to sell my product, then there is no point of producing it in the first place. So there is extended producer responsibility programs. We have discussed this earlier. So there we make direct contacts with the producers or other companies which can take our product waste directly, and then they can sell it or use it for some other purposes. Like for example, a bottling plant for some soft drink, they may take back the aluminum cans, and they may also give some incentives for the consumers to return those aluminum cans. Same goes for glass bottles, same goes for plastic bottles, and so on, right? Or PET bottles. So some amount of revenue generation is also involved in this, right? So that means the consumer gets certain amount of revenue, and that actually makes sure that they will recycle. So overall, recycling leads to cost savings in collection, transportation, and disposal, because once the recycled product is ready, then it's the responsibility of the recycler to process it further and so on. So the cost gets into their processes, the cost becomes a part of their processes. So the ULB doesn't have to spend money on transportation, collection, and disposal. Reduction of imports of raw materials like fertilizers, raw materials and fertilizers and so on. So sometimes our country imports fertilizers from outside or imports raw materials which is used for making certain kinds of materials. So if I do composting and all, obviously I will reduce this kind of imports. Then livelihood opportunities in the recycling industry. That means you can create jobs. So that's a good point. And finally, sustainable use of resources. Now, the recycling program of ULBs are different. That means, as per the law, it is now mandated. So, every ULB is now looking into how to expand these recycling programs. Now, first of all, there has to be a political will, and we have to develop the institutional capacity to implement those political wills, of course, right? So, both is important. Community awareness and willingness to cooperate. So the community has to be involved. So first of all, we have to tell them that this is what we are deciding to recycle. You have to segregate this kind of waste and so on. And also people need to participate in this program. Then establishment of material recovery facilities. So without this kind of facilities, you cannot do any kind of recycling program. Supply and market demand assessment for segregated materials. So we have to do the market demand assessment first. Quality and quantity of recyclable materials as per industrial requirement. I can recycle, but it may not match the quality required by the industries, right? So they will not accept it. So whenever we are designing a recycling facility or the recycling processes, it has to be done in such a way so that the industrial requirement is matched, right? So that means we produce good quality recycled materials. Market establishment by ULBs for recycled materials. So ULB has to engage with industries and other recyclers so that they can dispose of their products. Industry initiatives, either voluntary or mandatory EPR, as we are discussing right now, in collection, buyback, and recycling. Then a vibrant Kabaddi system and participation of the informal sector. So usually in Indian cities, the households sell their papers, some plastic directly to waste pickers or directly to informal recyclers, and this is the Kabaddi system. So if that part is very vibrant in a city, that market linkages are there, or the market is already existing, we can actually promote it further, right? So this kind of industry helps in the overall recycling process. So one example is the Go Green with Tetra Pak in Mumbai. This campaign was adopted, which helped in recycling of lot of Tetra Paks or some form of packaging material. Now, coming to potential of material recovery or recycling in municipal solid waste, as you can see from this graph, around 47% is organic, paper is around 8.1%, plastic 9.2%, metal 0.5%, glass 1%, rags 4.4%, others 4%, and inert material around 25%. So we have a huge potential for material recovery. So this is the part which we can recover. So this is the part which goes for composting or even biomethanation. This is the part which we can recycle and recover. So in India, out of the overall 1,43,000 metric tons of waste generated per day, we can recover around 10 to 20%, and which comes to around 14,000 or roughly 15,000 to 30,000 metric tons per day, which is quite a lot of amount of waste which we can generate, which we can recycle. Sorry, and this, but to set up any kind of recycling program, we have to really look into the waste characterization of a particular city. Even though this shows the general waste characterization in India, but whenever we are setting a program, it's for the ULB itself, right? So we have to look into the waste character for each city because that varies from city to city. And waste recycling plan should be drawn up actually based on what kind of waste is generated, what kind of segregation strategy is being adopted, and what kind of waste transportation strategy is being adopted. All this influences the recycling strategy for the particular city or ULB. Now, coming to the different types of items that are available in municipal waste and how we can recycle them. For example, aluminium is there. It has got quite a bit of market value, and we can keep on recycling it indefinitely. That means we can keep on melting it, and we can first shred it and then keep on melting it, and then whenever we melt it, it returns back to its original quality and specifications, right? So we can keep on recycling it. Energy used in recycling is less than virgin material procurement. So we have to mine aluminium, process it, and then make it into an aluminium can. Instead, you gather material from the urban area, you melt it and again use it. So this cost actually less. So of course, this is the good proposition for recycling. So collection system for aluminium is separate from other waste. That means it has to be separately collected. Otherwise, when it gets mixed, it will introduce a lot of contaminants. Batteries is something where it's not exactly value for money. For example, some valuable materials are there in battery, but not all types of batteries allow enough material recovery to make the process financially viable. But if I consider protection of environment from heavy metals and all, in that case, we should definitely take out batteries from the municipal waste stream. Then paper and cardboard, energy savings, of course, and protection of trees. So we save a lot of trees in this process. Recycling is easy, but there is gradual deterioration of the fibers because you cannot keep on using the paper multiple times. That eventually you will be using it as cardboard or packaging material, and then you have to discard it. Then PET bottles or polyethylene tetraphthalate. So that is where here also the quality reduces in each recycling cycle. That means you cannot keep on recycling it indefinitely, and only we can develop certain kinds of recycled products. So we cannot make it again into a PET bottle, but we can develop other sorts of recycled products using this particular kind of plastic. Then coming to C&D waste, it can be sorted, crushed, and then reused. Usually we use this kind of waste in construction of pavements or as road material, or sometimes it could be used as flooring tiles or even in landscaping of certain areas. And the idea is, of course, it's costly to do this kind of processing and all these things, but this will reduce significant landfill area requirement for the particular ULB. But there are not proper standards which are defined yet, so those has to be defined. Then coming to glass, the glass can be also, it's a moderate value. That means the amount of money you can recover is less, but we can recycle it indefinitely as well. The only problem with glass is glass has got different colors, and you have to separate each glass of different colors. Not all colors of glasses can be recycled, so it depends on what kind of dye are being utilized and so on, right? So energy savings compared to virgin material processing. So we will be able to save energy compared to virgin material processing in case of glass. And another one of the main reasons why we should do it is because it reduces contamination of other waste streams. That means glass gets mixed with other waste stream and it is hazardous, right? So that's why it's better to remove glass from the waste stream. Then coming to plastic, only same types of plastics can be recycled. That means it will be recycled into same thing. Values depends on distance to facility. If your recycling facility is far away, then there is probably you will not be able to make any money out of recycling. Mixed plastics can be co-processed for energy recovery and in road construction. In case the plastic is mixed and all, then you cannot recycle it directly, but you can use it for energy recovery, or you can burn it and also use it for road construction as well. Then thermocol or styrofoam, not everything can be recycled, particularly used ones not. Fully soiled and used ones, it's difficult. but it could be used as for burning, like pyrolysis, gasification, hydrocracking. These are different incineration processes. There we can use it as a fuel, but we cannot recycle it directly. It could be powdered to make sheets used in furniture production. So this is one form of recycling, you can say. Can be reground with new expanded polystyrene for further use to a certain extent. Then coming to metals, uh, all metals have got high market value, steel, copper, silver and so on. So if we can recycle them, we would be able to generate adequate amount of money, and we can keep on indefinitely recycling them. But the problem is when metals are embedded in plastic, that means we have a metal container with a plastic lid. Then when you recycle and then you melt the metal, this plastic will also burn. That will contaminate that particular metal. So we have to be careful about those kind of waste which has mixed plastic and metal together. And electronic waste also contains high value components. Some of it can be used or recycled, but the separation process is costly. And also again here a lot of plastic is embedded into the electronics and all this, or inside this kind of waste. So it may result in emission if not done under controlled conditions. Now, just to elaborate further, we have paper, cardboard, glass, metal, oil, plastic, batteries, this kind of waste in our waste stream, but not all of them are recyclable. That means not all paper is recyclable. We can recycle newsprints, means newspapers, office paper, computer paper, phone books, grocery bags, paper cartons, but soiled paper, wax or plastic coated paper, paper laminated with foil or plastic, used paper towels, napkins, tissues, these cannot be recycled, right? So not all paper can be recycled. Same goes for cardboard boxes, some single corrugated packing boxes, cartons, cereal boxes for morning breakfast. So those kind of things can be recycled. Whereas waxed boxes, waxed milk cartons, the one with nice smooth layer surfaces, those cannot be recycled. Say glass, again some bottles can be recycled, whereas bulbs, window panes, glassware or mirrors, this cannot be recycled because of extra coatings and other processes that are being given to this particular kind of material. Plastics, again, some can be recycled, some can be not. Batteries, it can be mostly recycled, but maybe it's not that much viable financially. So, as per the Software Management Rules 2016, now we have every ULB has to set up material recovery facilities, and MRF is a facility for, as defined by Solid Waste Management Rules 2016. MRF is a facility for temporary storage of non-combustible MSW to facilitate segregation, sorting, and recovery of recyclables and subsequent delivery to processing or disposal sites. So that means MRFs are areas where we don't process it. Sometimes we can process it, but usually it is for segregation, sorting and recovery. So if you want to process the waste further, like you want to bale it and all these things, or you want to make it into some pellets and all, you have to take it to some other plant. But sometimes this sorting, recovery and also baling of waste is done together. So that means primarily material recovery facilities are for recovery of the material, not for further processing it. But some amount of processing can be done as well. MRF will have sufficient space for sorting of recyclable materials like plastic, paper, metal, glass and textile and so on. And there has to be involvement of informal or authorized waste pickers or waste collectors for separation and collection of recyclable waste. So we engage informal workers usually for this. There could be mechanical processes also which we can involve, or it could be a mix of mechanical and manual processes. But usually in Indian conditions, we have found based on the kind of waste we get, it's better to use manual segregation, and it's also affordable at this point of time. But in future, we may find that to be very costly, and we may have to totally shift to mechanized processes. Transport of non-biodegradable waste to processing facility is also a part of this particular rule. So, as we were discussing earlier, households usually segregate the recyclables like newspaper, cardboard, plastic bottles, and then they sell them directly to local recyclers, scrap dealers or waste haulers. So, this is the Kabadi system. So, in India, we already have a very, very robust this kind of recycling collection system at the household level itself, right? and unsold material goes into the whatever cannot be sold by the household goes into the municipal waste stream. So that is where we are, and that means if I can improve this part further, then the total cost of recycling for the ULB would be definitely reduced, or the amount of material that the ULB has to recycle is also be much less. Then waste pickers, we have a ban on manual scavenging, of course, but still there are waste pickers who are engaged, and some of them used to collect mostly from this recyclable materials from the community bins. So this is sort of sorting of waste from the community bins itself. And then nowadays, because we are doing segregation from door to door, so properly, if the waste is properly segregated, then this can be once it is, and then we can recover that waste. If it is, and if the household is actually segregating some amount of recycles, not only they are segregating dry and wet waste, but they are also segregating some amount of recyclables, directly we can send them to the processing site or to the recyclable market. That means vehicles will come, primary collection vehicles will come, and they will take up this waste directly to those processing sites or this recyclable market. So if you are doing it at door to door. But in most cases, we don't do it like that. In most ULBs, we are now having dry waste and wet waste categorizations. So usually there are two containers, dry and wet waste. Wet waste is the organic waste, whereas dry waste is actually considered for further recycling. So recycling is done at the transfer station or at the processing plant. So this MRF facility could be within a transfer station, along with the transfer station, or it could be a processing plant as well. That means wherever we are creating pellets for refuse derived fuel, or we are doing some amount of other processing, there we can set up these sorting centers and all, and we can also engage informal waste pickers as well for this. But sometimes what happens, if this facility is far away, it's a regional facility. In that case, instead of taking all this waste there and then doing the sorting, if I can set up some decentralized facilities at the local level, or even a centralized facility at the city level for doing some amount of sorting and all, then I will categorize the waste into different categories there itself, and then directly take it to the respective processing facilities. So I don't have to waste time in again retransporting them back between the processing facilities or from processing to the landfill site, right? So some sorting could be done at the urban level as well, ULB level, in this MRF facility. So we can set up decentralized facilities at the ward level, where segregation and transfer of recyclables to recycling facilities or wholesale dealers takes place. So first we segregate and then we transfer them, and then the remaining residual waste can go for for RDF, landfilling, or even composting. If we have got mixed waste, then we also get waste for composting as well. So that means we first take out the if I have got a mixed waste stream, I will first take out the recyclables. Whatever remains, then I will find the organic part, the inorganic part, and the inorganic part will go to RDF. Whatever cannot go to RDF, that is whichever has calorific value less than 1500, it will go to the landfill sites along with the inert material. And all this processing could be done manually or via mechanized means. Now, in the processing side, that is not in MRF, that means the processing side where we either produce compost or RDF, there also we can engage manual or mechanical pre-sorting. That means before we actually do the process of actually converting that waste into something usable, we can do some sort of pre-sorting of waste to take out either the the recyclables, or to take out some other inert materials and so on. And similarly, special waste such as domestic hazardous waste, it has to be segregated from dry waste at MRF and then disposed to a TSDF. So this is where this hazardous waste is being dealt with, and this is again also a disposal facility, and that we have to also, that means instead of sending to a MRF, we will send it to a TSDF. So this image actually illustrates, this is from Zhu et al. 2008, and we have adopted it from CPHEO manual. So you can see that waste is being generated. Some can be used as animal feed in the house itself. Some can be, we can do local organic composting inside my residences, and we can use it for agriculture, or we can segregate the waste, then we can send it to a primary collection. This does through primary collection, it goes into the transfer station, and some pre-sorted recyclables can be already sold to the Kabaddi system. From there, it can go into the different waste streams for plastic, paper, and all, and eventually it reaches the recycling industry. Or through transport, through this transfer point, we can do this MRF. We can set up the MRF facilities where sorting is done, and then again we can, take it to this intermediaries, and finally it goes into the recycling industry. And in between, waste pickers can also get waste from the community bins and again sell it to the divide the waste into different categories and sell it to the different recyclers. So from transfer point, some amount of waste is transported to the processing and treatment facilities, and some from there the rejects goes into the landfill site. Some amount directly is taken to the landfill site, of course, and the other goes into the organic facilities where organic waste is taken to the composting facilities, and eventually we can use the compost. So more or less, this is how the materials can be recovered from the waste stream. So now we will talk about some case studies, like for example, whenever we are talking about setting up material recovery facilities, we have to decide what amount of land is required, and we have to include this in our master plan. That means in master plans, we have to make provisions for land required for setting up this MRF within the city itself, maybe the decentralized ones, right? And stored waste within the MRF, the stored waste should not be exposed to the atmosphere. So, of course, it should be within sheds and all. Recycling centers should be set up at ward level if possible. If not, at least for a group of wards, we can set up one facility. And the design of the MRF processing line, that is the sorting line, that has to be designed properly. It is based on the quality and the quantity of the waste that we receive. If it is mixed waste, the sorting line would be different. If it is segregated waste, the sorting line would be different. The desired processing rate, at what rate I am going to recover the material. So if I want to recover more, so I have to have more number of people engaged, so the processing line should be bigger. And specifications of the end product, how much categorizations we want to recover. That means, should I recover paper and then different categories of paper, or plastic and different categories of plastic? So what hierarchy of waste, that has to be determined based on what is my requirement for end product. So if in case of Panaji, as you remember from, we have learned this earlier as well, here the waste is divided into 16 fractions. Why? Because the city has made agreements with Tetra Pak companies. They have made agreements with this milk plastic packet companies to send those packets back to them, right? So of course they will have so many fractions. So not only plastic, they will subdivide it into Tetra Pak, then they will make this milk cart plastic and all these things, right? So from 2021 they have started dividing the waste into 16 fractions, and out of this they have non-biodegradable waste is sorted in 14 sorting centers. As you can see over here, this is manual segregation is being done, but we are using a conveyor belt. The waste is first loaded, put into the conveyor via some hopper, and then from the conveyor belt people can pick up the waste which are to be recycled. And plastic, paper are sub-segregated. So that means paper and plastic are further categorized, like based on quality and color of those particular material. And finally, bales of paper, plastic, Tetra Pak, cloth are prepared using baling machines, and then they are transferred to the respective processing sites, right? And usually they are generating around 1 lakh rupees per month from the sale of recyclable items. And there are shops in that ULB in Panaji which will collect PET bottles, cardboards, milk packets or metals in exchange of notebooks, pens and erasers. That means people will get this notebooks, pens, erasers if they can give this PET bottles, cardboards back to those particular shops, thus reducing the effort of the ULB. That means thus reducing the investment of the ULB as well, right? So that means whenever we are setting up a MRF facility or a recycling plan, we are preparing a recycling plan for an urban area, we have to make agreements with different recyclers, we have to design systems of collection, Some of it could be voluntary like this, some of it could be like, mandatory collection and then segregation and sorting. So we have to overall plan this entire process. So next, coming to the Dhenkanal Municipal Council, they set up the first MRF facility in Orissa. Now they have got 3 MRFs, and they are using self-help groups, Swat Sathis, to do this kind of sorting. Manual segregation of non-biodegradable waste into recyclable and non-recyclable fractions. They sell the rates fixed by the ULB. As you can see that these are the rates fixed by the this ULB. Plastic bottles 10, paper ₹5, and this is per kilogram, right? Metal ₹3 per kilogram, rubber ₹10 per kilogram, and so on, right? So this is the rate that has been fixed. Non-plastic materials are sold to kabadi wallahs through formal agreements. So that's paper and all those things are sold to those kabadi wallahs, and there are agreements in place for that. The overall revenue that they are generating is used to run the MRFs and for payment of this Swat Sathi workers, right? So that means they are utilizing the money they are generating to do the payment and to operate this kind of facility. The non-recyclable materials which cannot be recycled directly, we can have option to make them into this refuse derived fuel. So they are employed EcoCar Technology Private Limited. They collect around 150 tons of RDF and they take it to the Baragarh cement plant where they are used as fuel. And non-recyclable plastics could be is converted into PVC paver blocks in a plant constructed by DMC themselves. Whatever revenue is generated by this plant is again used for payment of SHGs, self-help groups, right? Then coming to Bhopal Municipal Corporation, here MRF is done at a very large scale. It's very effective also. They have 6 non-biodegradable MRFs and 5 biodegradable waste processing plants, 3 windrow composting and 2 biogas plants. We will learn about this windrow, biogas, all these things later on. Biogas is the biomethanation part, right? So organic waste is either composted or we do biomethanation. So whereas we have 6 non-biodegradable MRFs, and you can see the list of these 6 plants over here, and the capacity of this plant ranges from around 50 tons to even 400 tons. So this is a centralized one, right? So it is a big one, whereas these are smaller ones. So in addition to this, they have a 400 tons per day charcoal plant, which is run by NTPC, and non-recyclable, non-biodegradable waste is actually used by this plant, and this is used as fuel, of course. And Bhopal Municipal Corporation gets royalty per annum for this particular waste. So you can see the image of one of this recycling center or this material recovery center. So these are some of the references you can study. To conclude, every ULB should prepare a material recycling and recovery plan, and material recovery facilities needs to be designed as per the waste stream characteristics, degree of segregation, and the final market of the recycled or recovered material. And ULB should actively develop market linkages and EPR programs. Thank you.